Hello student, how are you? I'm Arunsir. Welcome to my channel Tuition Expert. Today in this class I'll teach you some important problem on the chapter laws of motion. These problems are very important for NEET exam and JEE main exam. Especially some conceptual problem on friction will be discussed in this class. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the JEE main exam and NEET exam confidently with a good rank. Now let's start about the class. I have written first problem. A horizontal force of 10 Newton is necessary to just hold a block stationary against a wall. This is the diagram. That is, this is a wall and a block is held by a force which is applied on horizontally against the wall. Coefficient of friction between block and wall is 0.2. Now the weight of the block is what? That is, here weight is not given, force is applied on the block and it is held against the wall. Then you have to calculate the weight of the block. This is the question, simple question. So I hope all of you understand the problem. So this is the wall, and a block is held. Suppose weight of the block is m. So weight acts vertically downward. Now a force act in this direction. So what is the weight of the block? Now due to weight of the block tends to move downward along the plane, along the wall. Now the friction holds the block upward. So what this is the friction force. Friction force act along this direction. Friction force acts along this direction, which prevents the weight of the block. So what is friction? Friction equal to, we know, mu into normal action. Here weight, not the normal action is not weight. Normal action is always normal to the surface. So this will be the normal action, which is equal to F, because this is action, so this is reaction. So F equal to N. So here N equal to F, that is applied force. Now what is force applied? Force is 10. Now mu equal to what? Mu equal to 0.2 into 10. So this is the friction force. This friction force prevents the block. So friction force equal to weight of the block. So weight equal to what? Weight equal to 2 kg. Weight equal to 2 kg, 2 Newton. The weight of the block is 2 Newton. Simple question. Weight equal to friction force. Weight equal to friction force. So now next question. Second question, very important, very conceptual. Now 2 kg block is placed over 4 kg block and a force F equal to 24 Newton acts on the 4 kg. The ground is smooth. Mu between the two block is half mu, that is between two blocks. This here coefficient of friction is half. The mu between two blocks is half. The force of friction acting between the two block is what? Force of friction acting between two block is what? So this is the question. Now this is very conceptual. Suppose two block is present here and 4 kg block is present here. Force F equal to 24 Newton act. Now what is the friction force act in this diagram? So if we write the friction force equal to mu mg, so answer will be mu equal to half, am is 2, friction force you have to calculate friction at here. So write the maximum friction force, which is equal to mu mg, am equal to 2 into g 10, that is 10 Newton. Then this is wrong. This is wrong. Actually F not will be this. So always maximum friction we calculate, but always friction force will not be maximum. So what is the friction force act? We have to calculate. Now I have told my video block on block, that is in friction chapter, what is the condition for two blocks move together, and if what is the condition for two block move together, and what is the condition two block move separately. I have told this in details. You can watch my video. Okay, you can watch my video. Now a maximum is not 24 Newton. 24 Newton is not maximum force for which two blocks move separately. Suppose we calculate the maximum force for which two blocks move separately. Suppose limiting value, up to that limiting value two block move together, and after that value two block move separately. If the block move here, the friction force act in this direction and friction force act on the block this direction. So friction force here mu mg equal to mm cancel, so a equal to mu into g. Now this block moved with a, so f minus, here friction is mu mg. Suppose this block is m1, this block is m2. F minus friction force mu m1g equal to ma m2 into a. What is a equal to mu g. So F should be mu into m1 plus m2 into g. Now if we put this value, what we get? The value is mu equal to half. What is the value of mu? Mu equal to half into m1 plus m2, 2 plus 4 6 into g 10, that is 30. So if the force applied 30 Newton, then the two blocks move together, and after that 30 the two blocks separate. Now the 24 Newton less than 30, so we can easily say that two blocks move together, as the maximum force 30. After 30 two blocks move separately. Now up to 30 two block move together. So now 24 Newton is less than 30, so now two block move together. So we can say that two block move together. If the two block move together, then we cannot, this is the force, this is the maximum friction force, external applied force is maximum up to that two block move together, then here we use maximum friction force. But the 24 Newton is less than 30, so we cannot use the maximum friction force here. Maximum friction force. This is not now apply. We here not maximum force. So what is the diagram? 2 kg block and 4 kg. So here external force is 24 Newton, and maximum friction, if the block moves in this direction with an external force 24, then the friction force act in this direction. So and the friction force here drives, so this is driving force. Now we cannot use here F equal to mu mg, because this is not maximum force. This is a maximum force is 30. If 30 Newton force applied, then we can use F equal to mu mg. But here maximum force is not applied, less force applied. So what is the friction force? We don't know. Suppose that friction is F. Now if this is F, then this is F act in this direction, this is driving force. So two block move together, so the A and A acceleration is same. So now write the equation. F equal to ma 2 into A, and here 24 minus F equal to 4 into A. Add, if we add we get 24 equal to 6 into A, which is A equal to 4. Now what is the friction? Friction equal to 2A, so friction equal to 2 into A 4, that is 8 Newton. So answer is 8 Newton. If maximum friction comes, then maximum friction equal to mu mg, which was half into 2 into g, that is 10 Newton. But this is not correct. Answer is 8 Newton. In my previous video, I have told details, block on block topics, friction between two blocks, friction among three blocks. I have discussed in details. You can watch my video. Now what is the problem? Problem number 3. Two blocks A and B pushed against the wall with a force F. The wall is smooth, but the surface is contact of A and B are rough. That is, this wall is smooth and A, B, these contact are rough. This is the contact. This is rough surface, but the wall and this block surface between wall and this block is smooth. Which of the following is true for the system of blocks to be at rest against the wall? That is, force greater than W plus W and WB is the weight of the two block A and B. F greater than this, F equal to this, F less than this, and system cannot be in equilibrium. So which of the following is true for the system of blocks to be at rest against the wall? Two blocks will be raised against the wall for what condition? Now if we draw the free body diagram, this is the wall. Suppose this is a wall and A and B, this is block A and this is block B. So first force is applied on the block B. First force is applied on the block B. Okay, F is applied. Now if B is applied, so B is at rest. So friction force act. This is weight of the block WB act in this direction. So friction here act. The friction force act prevents the weight of the body. Now F1 act in this direction. So between two contact surface, action reaction always equal and opposite. Now if F1 is act, then here F2 act. So F2 weight. Now weight of the body is WA. So due to WA weight of the body, this block tends to move downward. Now this friction prevents. So F2 here F2. So this is the diagram. Now the diagram, this is very smooth. This is smooth. So as this is smooth, no friction force act here. So now block A cannot remain in equilibrium. The block A cannot be in equilibrium. The block A moves. If the block A moves, then how can B is rest? Because B is always with the surface. B is contact with A. So A and B move together. So the system cannot be in equilibrium. Simple question. If as this force is 0, this is smooth, so A cannot be in equilibrium because here no opposing force act. Here weight and friction force act in this direction. So block A cannot be in rest. Now as B is in contact with A, then A and B move together. So the system cannot be in equilibrium. Whatever the force applied, system cannot be in equilibrium. 4. A block of mass M is lying on an inclined plane. The force required to move the block up the inclined plane will be what? So if we draw the diagram, suppose this is an inclined plane. This is an inclined plane, and a block of mass M is inclined at an angle theta. Theta is the angle of inclination. Now a force is applied. So what is the minimum force? What is the minimum force required to move the block up the inclined plane? What is the minimum force required to move? So tendency is move upward. What is the minimum force required to move up in the plane? So friction force is present. Now weight of the body act in this direction. mg sin theta act in this direction. Here friction is present. So if the block tends to move upward, then friction force act in the opposite direction. What is the friction force? Friction force equal to mu into r equal to mg cos theta. We know friction force equal to mu mg cos theta. So F equal to mg sin theta plus mu mg cos theta. All you know why the normal reaction is r. Friction equal to actually mu into r. Here r is normal reaction, because normal reaction act in this direction. How we get normal reaction? R equal, the component of the weight along this direction is mg cos theta. So that's why r equal to mg cos theta. So friction equal to mu r mu mg cos theta. Friction act in this direction because the block tends to move upward by the force F. So what is the force required? Now force required is this plus this. These are the two opposing force. So external force applied to move up equal to sum of two opposing force, which is mg sin theta plus this. Okay. If the students can clear their doubt, then the students can watch the friction topics which have been discussed in details. Now the next problem is a block of mass 1 kg is placed mu equal to this on the horizontal surface of a truck which is moving with acceleration this. Then the frictional force on block will be this. That is, a block is in the truck. So this is a truck. The ground surface. Suppose this is the floor of the track and a block is present on the floor of the track. Now the track is moving with acceleration 5 meter per second square. 5 meter per second square. Now what is the frictional force act on the block? What is the frictional force act on the? This is the question, problem 5, and here given mu equal to this, mu equal to 0.6. Now students can use generally what is the friction? Friction equal to mu mg. So if they write that friction equal to 0.6 m, what is the mass of the block? Mass of the block is 1 kg. 1 into g is 10. So this answer is 6 Newton. But this is not correct. This is not correct. This is not correct. So always we cannot use maximum friction force. Now the track moves with the acceleration this. Then what is the pseudo force act on this block? Pseudo force act in the opposite direction, which is equal to ma. So m means 1 and acceleration is 5, that is 5 Newton pseudo force act. Now external force act on the body is 5 Newton. So friction prevents this force. So friction force equal to 5 Newton. Friction force equal to 5 Newton. 5 Newton is the answer. 5 Newton will be the answer. 5 Newton will be the answer, not 6 Newton. Students make mistake that maximum friction equal to mg, so 6 Newton. This is not correct. Now we have to calculate the what external force. The block is raised on the floor. So what external force act on the block? This is pseudo force. Pseudo force equal to ma, mass into acceleration 5 Newton. So this force act in this direction. Friction prevents the slipping of the block, which is equal to 5 Newton. Friction prevents this force. Okay. A given object takes n times as mass time to slide down a 45-degree rough incline as it takes to slide down a perfectly smooth 45-degree inclination. The coefficient of kinetic friction between the object and the incline will be what? That is, question is two plane. One is smooth plane and another is rough plane, both is 45-degree angle, same length. One is smooth, that is one mu equal to 0, and another for rough plane mu equal to what you have to consider. Now this is this time is less time. So if this time taken is t, then this time will be nt, that is time taken to fall a body in smooth plane bt, then time taken for rough plane will be nt. So this is the given problem. Time taken is n times. Now what is the value of mu? Angle of inclination is 45 degree, and this surface, this length covered, the length covered by the object is s. Here is also s. So length is same, angle same. This is smooth, but this is a coefficient of friction. So that's why the body takes some time, because this is retarding motion, because friction opposes the motion of the body. So now you have to calculate the coefficient of friction. This is the problem. Okay. Now how we find the time? To find the time taken, we always use the equation of motion. So solution of 6. For smooth plane we know g equal to what? G equal to for smooth plane, what is the acceleration? For smooth plane we know acceleration equal to g sine theta, g into sine 45 degree, that is 1 by root 2. This is the acceleration. Now what is the equation of motion? Equation of motion will be s equal to 0 t plus half g into t square. This is the equation 1. Now for the rough plane, what is the acceleration? Acceleration of rough, acceleration along rough plane, what? So acceleration along rough plane, will be a equal to g sin theta minus mu g cos theta, which is equal to g 1 by root 2 minus mu g cos theta 1 by root 2. This is the acceleration along rough inclined plane. How a acceleration is find? This is this theory have been discussed in details my friction video. So now just I shortly show this. Just shortly I derive this. How what is the acceleration of rough plane? Now this is mg sin theta and in this direction friction force equal to mu mg cos theta. So acceleration is a, so ma equal to mg sin theta minus mu mg cos theta. That's why a equal to g sin theta minus mu g cos theta. So this is the acceleration of body along rough inclined plane. Now we use here the equation of motion. So equation of motion along rough inclined plane will be, so acceleration here puts theta 45 degree, this will be g by root 2 minus mu g by root 2. This is the acceleration of a body along rough inclined plane. Now equation of motion s equal to 0t plus half a, acceleration equal to this, so take common g 1 by root 2 minus mu by root 2 t square. Here time taken is nt this. Now this and this equal, so half g into 1 by root 2 t square, g2 into root 2 common, 1 minus mu n square t square. If we cancel g by 2 root 2 cancel, t square cancel, so n square equal to 1 by 1 minus mu, 1 by 1 by mu, n equal to root over this, n equal to this. So this is the answer, n square. Now we have to find the mu, so we have to find the mu equal, so 1 minus mu equal to 1 by n square, so mu equal to 1 minus 1 by n square. This is the answer, 1 minus 1 by n square. So mu equal to 1 minus 1 by n square. This is the answer. Now next, topic is what? A rope lies on a table such that a part of it hangs down the table. When the length of hanging part is 1/3 of entire length, the rope just begins to slide. The coefficient of friction between the rope and the table is what? So this is a table. And a rope lies such that a part of it hangs down the table. When the length of the hanging part is 1/3, so this is a rope. Suppose this is a rope, 1/3 is hanged. Suppose this part is 1/3 of this, 1/3 of the total length. So if the L is length of the rope, now this length will be L by 3. So this is the length L by 3 hangs. Now this is the in equilibrium. So to find the coefficient of friction between the rope and the table is what? So now the rope is uniform, so we take omega is mass per unit length of rope. Okay, so mass per unit length of rope. Now what is this length? This length is L minus L by 3, that is 12 by 3. Now what is the weight of this part? Weight of this part is this. Now weight of this part, hanging part is what? L by 3 into omega into g. This is the weight of the hanging part. This force pulls this part against this direction, this. So friction force act in the opposite direction, prevents the slipping of the rope over the table. So what is the friction force? Friction force equal to mu into mg. What is normal reaction? Normal reaction of the rope is the weight, due to the weight of this part which rests on the table, so the normal reaction here will be mu into r, which is equal to mu into 2l by 3 omega g, r equal to this. So friction coefficient this prevents the slipping of the body, slipping of the rope, so this must be equal to this. So mu into 2l by 3 omega g equal to this equal to this. So omega g cancel, l cancel, c3 cancel, so mu equal to half. This is the answer. L minus L by 3, that is 12 by 3, L minus L by 3, 12 by 3, omega g, this is friction balance the weight of this body. Now next problem is here. This is a ground, this is a pulley, and a block is attached with a string. This end of the string is pulled with velocity v. So the question is, a block is dragged on a smooth plane. This is smooth plane with the help of a rope. This is rope which moves with a velocity v as shown in figure. The horizontal velocity of the block is what? The horizontal velocity of the block is this. So what is the velocity of this block? What is the velocity of this block? Horizontal velocity of the block is this. So this question in details I have discussed in my video. Very complex problems will be can be solved if you watch my video. Pulley system, what is the tricks on the pulley system? So course 3 methods I have discussed. Just put here that relative velocity along the rope will be same. So if the velocity is v, then what is the velocity as in this direction? This is theta, this is 90 minus theta. So component of the velocity along this direction is v cos 90 minus theta, that is v sin theta. So v sin theta will be v, so v equal to v sin by sin theta. This is the answer. That is, the string, the length of the string is constant, so the relative velocity along the string will be 0. So what is the velocity? If the velocity is v, what is the velocity along rope? The velocity along rope is v sin theta. Now this is v. What is the relative velocity? Relative velocity is this minus this equal to 0. Because the string cannot separate, the length of the string cannot be increased. So that's why relative velocity becomes 0. The length of the string cannot be increased. So relative velocity along the string remain 0. So that's why v sin theta equal to v. So this. Now another method what? If the tension is T along the string, so T dot v, summation of T dot v equal to 0. That's why T dot v means dot product. So from this is T into if this the tension is T and velocity is v, so T into v into cos of theta. Theta is here angle between this and this, 90 minus theta, plus here tension is T tension is T, tension along this direction is this. If we pull, the tension is this, T into v cos 180 equal to 0. So v sin theta equal to v, so v equal to v by sin theta. Anyway, velocity becomes this. Next, a block, this is a table and 8 kg block is placed on the table. Coefficient friction between table and block is 0.5 and coefficient of friction between 2 kg and 8 kg is 0.2. Now if 25 Newton force is applied, then what is the friction between 2 kg and 8? The question is, what is the friction between 2 kg and 8 kg block by the force 25 Newton, and 2 kg block is present here, 2 kg, this is 8 kg. Now first friction opposes from the two sides. Now maximum friction act, which surface provides the maximum friction? If we calculate the maximum friction is in this surface, what is mu mg, that is 0.5 into m is 8g, that is 5 by 10, 40 Newton maximum friction force act in this direction, and here friction force is maximum friction force here equal to mu mg, that is 0.2 into 2 into g10, that is 4 Newton. Now applied force is 25 Newton. So among these 40 Newton is more than 25. So this force is not required to prevent the body. This friction force is sufficient to prevent the body. So this will not required. So here friction must be 0. Friction is 0. Among these two, among the friction, this body also exert the friction force when it is required, but here force is 25 Newton, which is, and here maximum friction force is 40 Newton, which is enough to prevent the 25 Newton. So this force is not required. So here friction force is 0. Okay, m is a block is present here a block is present here, and here is a rope of mass. This is a rope is present. So this is mass m and this is mass m. Now if force F is applied at here, if is applied here, what is the reaction force act in at here? The force which the rope exert on the block, that is this, the rope exert the block at which force? The force which the rope exert on the block. So here reaction contact force, you have to find the contact force. So to find this diagram, this is not F, this is not F. So here option 1 is given F, but this is not F. So what is the contact force? We have to draw the free body diagram. So just so this is a rope, and here F is applied, and this is reaction R, this is reaction R. You have to find this. Whole system moves with an acceleration, so this A, this A. So very easily we can find here equation of motion R equal to ma, and here equation is F minus R equal to small ma. Just F equal to what? So A equal to F by this. This is the acceleration. Now the R will be m into A, which is this. So this is the answer. Okay, student, this is the end of the class. To get more such type of video and more important problems for NEET exam and JEE main exam, watch my another video. Okay, thank you.